And yesterday in class, this is the 4th period video, so in class you did the evens. Today I will do the odds, record the video, and post it. The evens are already posted, so that way when you're studying, if you want to see one of them worked out, you can find it. Okay, first set is all with this table, and you kind of look through and you see quotient rule, product rule, chain rule, chain rule, chain rule. So number 1, that's a quotient rule, except that that's kind of cruel. Like you memorize the chain rule with, GF prime, GF's got to come first, GF prime minus FG prime. What's weird about number 1? They flipped F and G. So you got to be careful. It's not GF prime anymore. It's, I hate to even write it. For this problem, it's FG prime. All over F squared. That feels terrible to even write that, because that's not, right? Things are backwards for this problem. All right, and then at x equals 2. So rather than write parentheses 2, well, that'd be 5 times there. I'm just going to look at f of 2. F at 2 is 3. G prime at 2 is 1. G of 2, G at 2 is 6. And f prime of 2, f prime of 2 is negative 4. All over f of 2 squared. So the equation was tricky because things were backwards, but after that, 3 plus 24 over 9, 27 divided by 9 is 30. Number 3, f of g of x. So this derivative is going to be outside in, product rule, or chain rule, one layer at a time. So the outer layer is f, so f prime, leave the inner stuff alone, times the derivative of g, the derivative of the inside. And so at 9, this one, with all this nested stuff, I think it's probably wise to write it out, even though I did not do that last time. Because we're taking answers and plugging them in elsewhere. G of 9 is 6. Then I need f prime at 6. G prime at 9 is 2. And then f prime at 6 is pi. So I sure hope 2 pi is an answer, and it is. Chain rule. Number 5, find h prime of 10. H of x equals f of x minus 1. So h prime would be f prime of x minus 1. Times, chain rule, what's the derivative of x minus 1? 1. So, well, I already put the times, so I guess I may as well put times 1. That doesn't really do much. So h prime at 10, so 10 goes in for x, is f prime at 9. So that, in some ways that's easier than all the others, just got to know what you're looking for. F prime at 9 is negative 9. Number 7, use the equation of a line tangent to the graph f of x at the point when x is 2 to approximate 2.5. Okay, we've done this a few times. Always makes a good free response question. I think it was one on the last test, so remember if it's this one or not. Okay, so I need a tangent line at x equals 2. So I need a point and a slope. The point is 2 comma something. The slope would be the derivative there. That'll give me the tangent line. So maybe I should kind of lay out the process here. That'll give me a tangent line, and then I'll use the tangent line to approximate f of 2.5. That's sort of my big picture, like map out the problem here. So f of 2, again I'm still with the table here. F of 2 is 3. That's just in the table. F prime of 2 is negative 4, again from the table. So my tangent line would be y minus 3 equals negative 4 times x minus 2. So if I move the 3 over, then my tangent line I can use as an approximation for f of 2.5. So I'm going to put the little approximation signs on there. So I'm just going to plug in 2.5. And that's a safe stop, although that one's not hard to do. Plug in 2.5. Now, I didn't plug it into the function, so this isn't actually what the function is. But whatever this function looks like, presumably the tangent line is going to give me something pretty close to the function. I don't want to do that. Leave it alone, right? Safe stop. I don't want to mess that up. Half of negative 4 is negative 2, plus 3 is, I think. Find the slope of the line tangent to the graph, also known as derivative. Oh, natural log of all of that. What's step number 1 on this one? Is it an algebra step or a geometry? Or a geometry? Definitely not a geometry step. Algebra versus calculus. Algebra. Yeah, let's split this up. Let's do some algebra. Natural log of x squared plus natural log of the square root of x cubed minus 1. Which, I mean, I could do it from there. That's still better, but I can go one more algebra step. 2 natural log x plus 1/2 natural log x cubed minus 1. Yay for algebra, because it makes my calculus easier. And this is the importance of labeling what you're doing, not just writing stuff down, but taking the extra 2 seconds to write g of x equals. You're sort of emphasizing that I haven't taken a derivative yet. Now I'm ready for a derivative, so I will label it g prime. So 2 over x, that's an easy one, plus 1/2 x cubed minus 1 in the bottom, 3x squared in the top. And it doesn't match because I've got to do some. Okay. Yeah, my denominators look good. Although, yeah, I've got to just get a common denominator here. So this one needs another x, top and bottom, and this one needs a 2 and an x cubed minus 1. So let's see. That would be 4x cubed minus 4 plus 3x cubed all over 2x x cubed minus 1. So do I have a 7x cubed minus 4? Yes, I've got 2 of those. And I also need that 2 in the bottom, so answer choice B. The order of that problem was algebra, algebra, calculus, algebra, algebra. So I hope your algebra skills are good, right? Because we keep using them. Number 11. Find the slope of the line tangent to the graph, derivative, at the point 1/4, 0. What rule am I going to need for this? E to the x times log base 9 of 4x. Product rule. So this one looks kind of ugly, so I don't think I'm going to do... Sometimes I just do product rule in place, like fg prime plus the other way around. This one, those are both new to this unit, so I think it's worth the time to like slow down and write both of them out and then piece it all together. Alright, derivative e to the x is e to the x. That's the easy one. Oh, derivative of a log base, not e here. So 1 over 4x times 4. Where does the natural log 9 go? Top or bottom? Bottom. And you look at your answer choices, that's the issue. There's some in the top and there's some in the bottom. 4's cancel out, so that's 1 over x natural log 9. But now I've got to put the pieces together, so we'll do fg prime would be e to the x over x natural log 9 plus e to the x log base 9 of 4x. And we want to plug in 1/4. Ugly thing to plug in here. So we'll do that evaluate bar there, so I can throw an equal sign on there. So e to the 1/4 over 1/4 natural log 9 plus e to the 1/4 log base 9 of, I'm almost out of space, but 4 times a 4th is 1. Log of 1, that's something. Log of 1, that means 9 raised to some power equals 1? 0. So that'll wipe out that whole second piece there. And that made things a little bit better. A 4th in the denominator would flip that 4 to the top. So 4e to the 1/4 over natural log 9. Surely that's a choice. Answer B. Another one with a lot of calculus and a lot of algebra. Log of 1 is 0. A 1/4 in the bottom. Some people still struggle with how to handle fractions. So, algebra and calculus. 13. Speaking of algebra and calculus, I want to do algebra first. Natural log of e to the x minus natural log e to the 2x plus 1. Split it up. Speaking of algebra first, picking on people here. Get you talking some. Kinley, what's the natural log of e to the x?
1.
The natural log of e is 1.
E to the x.
So I can move the x down front, and then the natural log of e is 1, so it's just x. Another way to say that is natural log and e are inverses. They undo each other. So the natural log of e to the x is just back to x. Yay, algebra. Now I'm ready to do a derivative. So 1 minus e to the 2x plus 1 in the denominator. In the numerator goes the derivative of e to the 2x plus 1. Owen, what's the derivative of e to the 2x plus 1?
Would it be e to the 2x?
Very nice, 2e to the 2x. So the e stuff stays the same, but the chain rule brings down a 2, and the derivative of 1 goes away. And why is that not one of my answer choices? I'm definitely not canceling those. Don't do that. This one's being added, so that's not eligible to cancel. So I have two terms. I think I did this right. My answer choices, well, that one has two terms, but that one looks like they forgot to take the derivative of x. So I think I'm going to need to add fractions. So this first one needs a e to the 2x plus 1, top and bottom. Algebra, algebra, algebra. So e to the 2x minus 2e to the 2x would be negative e to the 2x plus 1 over e to the 2x plus 1. Maybe that's an answer choice? Yeah, the order is backwards or different, but B. Algebra, algebra, algebra. Your algebra skills. Put them to the test. Number 15. Given f equals cosine of 2x, g is the inverse. Oh, an inverse problem. So this is the table thing. F and g, the point and the slope, or the derivative, however you want to phrase that. And yes, it takes a little time to set that up, but it's well worth it to keep the information organized. Okay, so I want the derivative of g at 1/2. So there's the box I'm looking for. 1/2 right there means that's the x value for the g function, which means it's the y value for the f function, which means I need to figure out what the x value is. So 1/2 is the y value. So 1/2 equals cosine of 2x. Okay, let's don't worry about the 2x part yet. The cosine of what is 1/2? So like what angle has a cosine of 1/2? Pi over 3. So I need what's under my pinky finger to be pi over 3. I need 2x to be pi over 3 for that to work. So I need x to be pi over 6. Okay. Again, big picture, I'm trying to get the bottom right. If I can get the top right, I know that those are reciprocals. So I'm getting close. Let's take a derivative of f, plug in pi over 6, and then flip it over. So f prime, derivative of cosine is negative sine. And why is that not correct? Derivative is negative sine 2x.
Is the derivative of 2x?
Need the derivative of the 2x. I need to be quotient or chain ruling here. Alright, so at pi over 6, negative 2 times the sine of pi over 3. Sine of pi over 3 is root 3 over 2. So negative root 3. Oh! I just did the mistake that I was going to try to warn people about. Why is my answer not negative root 3? Because I need to reciprocal that. I got so caught up in finding the derivative and was so excited that I found an answer that was there, I forgot to flip it over. And the only reason I caught it was a free or multiple choice question, and I saw the reciprocal there, and I thought, wait a minute, I didn't do the reciprocal. So it needs to be answer C. (17), another inverse problem, I think. Maybe? No. Function h is defined by the natural log of f of x. Find h prime of 3. Okay, so the derivative of a natural log is 1 over f of x times the derivative of f of x. So, yeah, this isn't bad. H prime at 3 then is f prime at 3, f of 3, but they gave us both of these, so 1/2 over 7. And safe stop, thank you very much. Also known as 1/14. Okay, even fractions and fractions are okay for safe stops. (19). Ooh. Well, first go-to is plug in, but 1 minus 1 over 0, that's 0 over 0, that doesn't work. I don't think there's any algebra tricks I can do to that one. Right? There's no factoring, there's no conjugates. So what I think I have to do for this one is maybe remember that the definition of a derivative is that the alternative form of the definition of a derivative is that. And so maybe if I piece together who's what, I can take a derivative rather than taking a limit. So let's see if we can match up the pieces here. F of x looks like it's 5 to the x. C would be the 0. Yeah, it's hard to, you don't really see it in the, if you put x minus 0 down there, maybe that helps. So that means what they're asking me is for the derivative at 0, where f of x is 5 to the x. This is a tricky one because there's no way to do it other than to recognize that it's a derivative question. So let's see, the derivative of 5 to the x is 5 to the x times natural log 5. And then if we plug in 0, 5 to 0 is 1, natural log 5 is an answer. Ooh. That's a hard one. It's a hard one because you don't recognize what that is. Your brain probably doesn't immediately jump to that definition. The good news is, later on in calculus life, like this semester, maybe next semester, there's another way to work that problem. We don't know it yet, but it's easier. 21. Which of the following is true? So this is just a straightforward derivative question. Derivative of sine is cosine. derivative of e to the negative x is e to the negative x, but the minus sign because of the chain rule, and then plus 3. Cosine of x minus e to the negative x. Oh, second derivative, third derivative, fourth derivative. That's the problem. Okay, so there's the first derivative, but that's not right because of that 3x. So I guess let's take a second derivative. I hope we find this before I get to the fourth derivative. Derivative, do you know? Derivative of cosine is negative sine. E to the negative x, but negative would make it positive, so plus e to the negative x. Derivative of 3 is 0. Dang it, so it's not b because that 3 shouldn't be there. So I hope the third I guess if it doesn't work, it's got to be d, right? Derivative of sine is negative cosine. Well, derivative of sine is cosine, but the negative's already there. Minus e to the negative x. Stop it already, people. Come on. So I'm pretty sure process of elimination, it's d. If we really want to go next level, then maybe we actually take the fourth derivative. Derivative of cosine is negative sine, but negative negative makes a positive. Speaking of negative, negative makes a positive. What a terrible problem. Make you do 4 derivatives to confirm that it's right. 23, and final. If y equals e to the nx, where n is a non-zero constant, then the nth derivative. Okay. So I think I just want to start taking derivatives and see if I can figure out what the pattern is. So the first derivative would be e to the nx times n. The second derivative is still going to be e to the nx, but now it's going to be n times n squared. If I do it again, e to the nx times n is n cubed. Okay, I'm getting the hang of this thing now. So the nth derivative is, okay, so when I get down to the nth row, it's n to the n, e to the nx. Ugh. Yeah, I think that's it. Factorials don't work here. And yeah, there's the first derivative and the second derivative, but the nth derivative would be over there at a. Yuck, yuck, yuck. Lots of algebra, lots of calculus.
Do you think the questions on the test would be easier?
Most of them, yes, but not all of them. Briefly talking about the test, we still got 5 minutes, and I'll show you one more thing. So obviously this is just me making notes to the side while I was working the test. 25 multiple choice questions, 3 points each, makes 75, with an iHeart Calc if you would like. So you have a skip in there if you don't like one of them, or the +3 if you want to take a chance on things. There's one 4-part free response question worth 4 points each, so that's 16, that makes 91. Here's my, as I did the key, I was just taking little hash marks on what I saw, or what was the main thing of the problem. So that probably doesn't add up to 25, because a lot of problems had multiple things in them, but you definitely used some graphs, definitely some log problems, definitely some exponent problems, not very many inverse problems. Shame on me, that's not a well-balanced test. And then, I don't know, I can't even read my writing, but that's 4 or 5 or 6 review questions. Although we saw 2 of them on the warm-up. I was also going to keep track of product, quotient, and chain, but they happen so often that I was like, they know product, quotient, chain. We don't need to worry about that.